The content that we have today, we hope it's useful for both group of people. Here is a brief agenda. So I'll start out by giving some overview of asset analytics, like what are some of the capabilities, what a typical workflow looks like, what, from a very broad view, what the architecture of the system is, and what are like some of the design trade-offs that we had to make. With that knowledge, hopefully, when you go and deploy asset analytics for your use cases, at least you can figure out like whether it's a good use case for the product or not. After I'm done with that, I'll just hand it over to Petrit, who will talk about best practices for some of these aspects, like building configurations, deploying your calculations, managing them, backfilling, and recalculations. So asset analytics, as some of you already know, is a feature that's shipped with AF. It's for writing streaming calculations in a simple configuration-driven environment. We ship the product with 150 plus built-in functions, simple math functions, statistical functions, functions for dealing with time series data, for doing summaries. Quite recently, we added some functionality which lets you work with the range of values and some array functionality. Once the calculations are configured, you can schedule those calculations to either trigger when new events for your inputs arrive, or you can choose a periodic calculation. You can say, okay, run my calculation every 10 seconds, every hour, 10 times a second, or whatever the case may be. You can use your calculations and map those results back to pi points. That way, you historize the results of your calculations as well. We also have analysis types for generating event frames. You can use these for tracking downtime events or any other critical events in your system. You have to specify a start condition and end condition, and you get event frames and you historize those. You can also do aggregation type calculations, what we call rollup. And the other one I don't have on the screen is SQC. The event frames that are generated out of analytics, you can then use those to trigger notifications to get alerts. One of the powerful features that AF has is templates. So when you create these calculations, you can easily templatize them. And when you do that, all those calculations automatically show up for all the assets that derive from those templates. It's fully integrated into PyAF. As I said, it's a system for doing streaming calculations. But when you develop these calculations, we also have functionality for you to backfill and recalculate your data. Very recently, I think within the past 2 years, we added this additional feature of auto recalculation, and that's when you get late arriving data or input data that's coming out of order. And when that happens, and when auto recalculation is enabled, your calculation results are automatically recalculated. So what does a typical workflow look like? In asset analytics and in AF, everything is centered around your assets. So this is a typical feed water pump. You will have a subject matter expert who really knows everything about this pump. They want to perhaps calculate some KPIs. They want to maybe do some performance monitoring. And they know what that business logic is going to look like, what that calculation logic is going to look like. They can use asset analytics to configure your calculation. And when they're configuring that calculation, it's typically an iterative process. They would configure the calculation, then test the results, run it perhaps against historical data and see what those results are going to look like. And once they're satisfied with the business logic and they have made sure that it actually works, they can then go and schedule it. When scheduling it, they can choose, as I said before, either a periodic schedule, or they can pick like, hey, trigger this calculation whenever a new event arrives for any of my inputs. So this works great. They can go and configure a calculation for one of the assets. As I said before, one of the powerful features of AF is templatizing those calculations. So let's say the calculation is configured, it's running. They can then go and templatize that, and as a result, that same calculation automatically gets applied to all the pumps that you have on your site or in your system. As soon as this happens, the analysis service, which is a Windows service that's running in the background, it picks up all these analyses that get auto-created within AF, and you will start seeing real-time data flowing for your outputs. So at this point, you have configured your system, you have deployed this calculation, it's running, it's producing real-time data. But one of the other capabilities is for backfilling and recalculation. So yes, your subject matter expert developed this calculation, it's running. And now you want to go and say, hey, calculate this for past 1 year or past 2 years, and then you have calculated data for whatever period of duration you're interested in. So let's talk about a little bit about context. So what I'm showing here on the screen, the screenshot is of a utility we call PySystem Explorer that many of you are familiar with. What AF lets you do is model your assets and processes. So I don't know if it's visible at the end, but it's showing the hierarchy and it's showing like a modeling of a compressor. And if you look at the attributes tag, those are all the measurements that are tied to that compressor. Now, what asset analytics lets you do is to write calculation logic using all the measurements on that asset or from somewhere in the hierarchy. So a typical use case would be like, hey, I want to monitor and detect problems with my compressor before they become catastrophic. So your subject matter expert would want to go and like write that calculation. They would typically use measurements from this asset or maybe one level up or two level up or down. Like you can do that using our relative path syntax or an absolute path syntax. But typically for these calculations, you would have maybe tens of inputs, maybe hundreds, probably not thousands. And these inputs are, again, coming in the context of that asset. The outputs are always mapped on that asset. So the way to think about it is these are calculated quantities that are now tied to that asset. So once I go and create these calculations, either it's KPI or like some efficiency metrics or whatever that might be, that's then tied to this compressor. And asset analytics in the background is running that calculation, and the results are being written back. Another kind of like a typical use case is aggregation. So let's say on the left, I'm showing a hierarchy of, let's say, some energy resources that are producing, and the customer is interested in aggregating the energy production from EV and solar substations. So in this case, your inputs are coming from that asset hierarchy, so everything under, let's say, a substation. In this case, you could have thousands of inputs. That's OK. And again, when those aggregations are calculated, that are then tied to that particular asset or with that context. Since they are now, they belong to the definition of that asset, you can always use them in dashboards, in KPIs, and reports. So the reason of me bringing out this thing about context is like analytics in general is a very broad concept. Like obviously there are different tools that do things differently. The cool thing about asset analytics is like everything is tied to the context. All your inputs are coming from your assets, and they're tied as a measured quantity. And when you go and look at those results, with whether it's a dashboard or a reporting or in data link or whatever the tool of choice might be, you still have the context, and you can backtrack what the inputs were, what the outputs were, and why I got a certain calculation result that I got. Now, let me talk a little bit about, from an architecture point of view, very kind of like a broad level. So some of the components that we have here is the AF server. That's where all your metadata configuration lives. This is a server that's backed by SQL. We have PyDataArchive. That's where all your time series data lives. Then we have the PyAnalysis service, which is a Windows service. It hosts what you can think of as an instance of the calculation engine. Now, all these components could be installed on the same box, but typically in a production scenario, they would be installed on different boxes, depending on how intensive your calculations are. If they are typically if they're resource intensive, you would like to install analysis service on a separate box. If you're using notifications, you can in fact install analysis and notifications on the same box. So let me quickly walk through like some of the steps that has to happen when analysis service starts, and like what are the kind of things that it has to do. So first, when you start your analysis service, it talks to the AF server, and it loads the configuration for all your analysis. Now, you could have a few hundred, maybe 10,000, 100,000 analyses. It just loads the configuration for all those analyses. Then it will, one by one, parse the configuration for all these analyses, figure out what the inputs are and what the outputs are. These are your AF attributes. Those are the inputs and the outputs. Now, we have this very important concept around data cache, because analysis service is highly optimized for running your streaming calculations. Most of the calculations, the amount of time is spent in getting the input data from your data source or writing the data. So that's called like an IO intensive workload. So most of the time, we are basically getting data in and out. So we want to make sure that all the data is available in the memory. So what happens is that when the analysis service loads this configuration, we would take all these inputs and add them to the data cache. And what it also does then is signs up to receive new updates for those inputs with the data archive. And we frequently poll for those updates. So once the analysis service has started, we start polling for new events on all of these inputs. And we have some mechanism policy. We know how much data each of your calculation is using. And as the calculations move forward, we start throwing away older data and keep on adding new data. So let's say all of that is done, and now your analysis triggers, which would be either on a clock schedule or when a new event arrives for some of the input. When that happens, we'll try to go and read data from the cache. So in this particular example, we are doing an 8-hour summary on this attribute A, so we need to go and get that data from the cache. If that data is available in the cache, then the calculation will be very fast, and we will go and do that in several milliseconds. But if that data is not in the cache, then we need to go directly to the source and fetch that data from the source, and then do the calculation. So the reason behind me even mentioning the architecture in this best practices talk is that just have this at the back of your mind when you're designing your calculations. And Petrit is going to talk about some of the tools that are available to figure out like what the load on the system is going to be when you actually go and like deploy this calculation. So keep this at the back of your mind that when calculations are running, majority of the time is in terms of like getting the inputs and writing the outputs. So when you're doing, let's say, a summary over a reasonable amount of time, whether it's an hourly summary or a daily summary, and that data can be served out of the cache, it will be very fast. You can probably trigger that calculation faster. But if it's a calculation where you're doing a weekly summary, then you have to be a little bit careful as to how fast you're scheduling that calculation to run. With all that, let me talk, and this is my last slide, so let me talk about some of the design trade-offs. So what is asset analytics highly optimized for? So this is highly optimized for doing streaming analytics, where all the data is in the cache, and you could be running calculations at a very high pace, and I think you can also run calculations at up to like 120 hertz if it's using just the current values, so that should work. Real-time calculations always take priority over recalculations. So real-time calculation is your streaming data is coming in, we are doing the transformation, doing calculations, and writing the result back. You can do recalculations, but that's always done at a lower priority. There are some tuning parameters that you can adjust if you want that to change. The design principle, again, is easy configuration. It's built for people who may or may not have any programming experience. So to use and write your calculation logic, it's like really simple configuration type stuff. Since it's optimized for those use cases, what is it not suitable for? So even though you could use it for like some of these use cases with varying degree of success, but typically what it would not be suitable for is, let's say if you want to execute queries across a really large number of attributes, perhaps like something that touches every single element in your asset hierarchy. So it may or may not perform that well there. Extracting large amounts of data for a large number of attributes, let's say you want to extract like years worth of data. So things, again, to keep there in mind is like, does that calculation make sense in a streaming fashion? So even though you can do that, like just keep that in mind. Obviously, you can use it to do ad hoc calculations, but that's not the primary use case. So, and the reason of me saying that is if these are all obviously legitimate use cases, and we want to enable you to do that with the PyData, but perhaps like some other OSIsoft product would be better suited for that. And if these are the use cases that you're interested in, come talk to us, and we can provide guidance on that. With that, I'm going to hand it over to Petrit.
Hello, everyone. Thanks, Nitin. My name is Petrit Duraku, and today I'm going to go over some of the best practices that you can follow to get the best out of our product. Some of the things that I'm going to show here today might be trivial, and some might require prior knowledge of the asset analytics. As Nitin mentioned earlier, the calculations that we provide are different types. Some are performance equations, known as PEs, roll-ups, event frames, or SQCs. In addition, these calculations can be scheduled to be event-triggered or periodic. Let's start with the basic performance equation. When building a calculation, we're given the capability to break down the logic of the calculation as much as possible into different expressions. These expressions correspond to named variables and can be mapped to output values. So the mapped output values is where you're writing the data. The named variables are very important when you're breaking down the logic because you want to name them in such a way that they're meaningful to you and describe what each expression is doing. So we really recommend that you break down the logic as much as possible, depending on what makes sense for you, So then you can really reuse the variables from one expression into another expression. Besides not just repeating a function from one expression into another, there are also performance improvements here because you're just using the same variable from one expression into another. It doesn't end up reevaluating the same expression or the same function if it's used in multiple expressions. So if you define a variable in the beginning and then use it in multiple expressions in the same calculation, it's evaluated only once, and therefore you're getting better performance results. A little neat trick to create a variable that I don't know if a lot of people know about is you can easily right-click the text within an expression, right-click on it, and then just say assign to a variable. This will automatically generate a variable for you, assign the expression to it, and then substitute the highlighted text with the variable. I thought it would be nice to mention. Another thing and an aspect to consider while configuring your calculations, I'd really recommend that you use comments. So for every expression or function you're using, it would be nice to add some comments to your expressions. In many cases, there are different people creating the expression and the calculations, and different people maybe maintaining them or reading these calculations. So it'd be very useful that you provide comments, so even in the future, if you look at it yourself, you might understand what's happening if the calculation is very complex. A nice feature that we've added in this new release is the exit function. What's the reason behind this? Let's say we have a calculation that we want to do some validation before we want to evaluate expressions. And to get around this is we introduce the exit function. Let's say we have bad values that we don't want to do a calculation for, or the pipe point is not hooked up correctly or something. You can check if you have a bad value, and if it's a bad value, maybe you can just say exit early, and therefore all the expressions underneath will not be evaluated. Another reason or example that I can think of off the top of my head is that the calculation could be triggering every day maybe, but maybe you just want your expressions to be evaluated once a month, maybe on the first of the month. You can get around this using the exit function by just checking if it's day one of the month, and therefore do the rest of the expressions or just skip evaluating. When we're mapping the expressions to output attributes, we're given the option to save history or not save history. So save in history means an attribute with a pipe point data reference is created underneath, and it's going to historize your data. If we're not saving history, then an analysis data reference is created, and the data will not be historized. We recommend that you historize the data as much as possible for many reasons. One would be you'll know what your system was doing in the past. You can also use the data from the past in current calculations and future calculations. It's also easier to investigate issues in the past, and you'll know how your system was performing in the past based on the data. But having said that, there are cases where you might not want to save history. For example, if you're passing a variable or a value from one calculation into the next calculation, then it's easy to just say, I don't want to save history, and just use the variable as an intermediate value. So this way, if you're breaking down the calculation into multiple, then you can pass the values around and not historize the data. In some other cases, we end up working or requiring to work with a lot of data from the past. So a calculation might require data from the past day, a month, and maybe you don't know exactly how much the range is, but you want to get the last 50 values or last 100 values. And you can accomplish that by using recorded values function or recorded value by count. You can just say, I want to get 50 values in the past, starting from now, and the recorded value by count will get the values. Why is this important? Because in your calculation, now you have at your hand 50 values, but you can use other functions on top to filter the data. For example, you can use the filter data function and get rid of all the bad data from those values, or get rid of data that don't meet the criteria based on some threshold. Or it could be the opposite. Maybe you're looking for values that are outside the threshold, and you want to find only those values. and then perform calculations on top of it, such as min, max, average, and all the useful performance equations that we have. And by the way, the UI gives a nice feedback. If you see on that eye icon, you can actually see the values in the UI if you do an evaluate to see what sort of values you're getting from the recorded values function. If you attended the previous talk today, I think from AF team, they talked about asset templates, AF templates. The AF templates are really useful, and they provide manageability, consistency, and governance. I was told to say those exact words. I'm not going to name names. So every time you have a repetitive work, let's say we're working with 200,000 calculations, and we want to make a single change to one of them, maybe add a new expression or a new function or change a time range, it will be very painful to go through every calculation and change it. If they are from the template, you can just go and change it in one place, and then that change will be applied to all the calculations across. So really recommend using templates as much as possible. They're also good for searching in the UI. You can easily search and find all the calculations that come from a single template, and you can list all that into the management UI. And they also help with performance because of the way the calculations are scheduled when they're from the template. So let's say now we have a calculation configured, and we're ready to check it in and let it run. Before we're doing that, we really recommend that you evaluate the calculation at least once in the UI by clicking that evaluate button. What that is doing is an in-memory evaluation. It's not writing any data out to the PyTags or anywhere, and it's going to show the results for that calculation at that point in time. This is useful because you get a sense, an indication how your calculation is doing. Are you getting the exact results that you expect to get? And in addition to that, if there are any errors with your configuration, they will show up at the bottom of the UI, and then you can make the changes before you actually even schedule it. In addition to that, in the bottom, there is also an indication on how long your calculation is taken to evaluate. This is just a single-time evaluation, and it just gives you an idea if it's an expensive calculation or not, if it's something to look into optimizing or not. Similar to evaluation, we really recommend also doing a preview on your calculation. You specify a time range in the past, and using your input in your calculation, you're getting to see how your calculation is doing going back in time. This is useful because if you were to do a backfilling or a recalculation using your new calculation, this is what would happen in the past. So this is the data that will be written. So you want to see if it actually makes sense for you and the calculation that you have written. In addition, if there are any errors, you'll get to see them here as well, and you get to see a nice trend of your data. Another thing to mention here is on the right-hand side, there are some metrics that are very useful about your calculation. These metrics give you an indication on how many evaluations happened between that time range, how long is it taking for your calculation to evaluate min, max, average, elapsed time, and so on. If for some reason the calculation is taking longer to evaluate compared to how often it's being triggered, in this case you will get a warning with a red circle that tells you just that. So it's a very useful tool before you even schedule the calculation to run in the system, and you'll know upfront if you might run into issues with such as delays and calculations backing up. So I would really recommend you use this before you start scheduling your calculation. Speaking of expensive functions, I think Nitin touched base a little bit on this. And some of summary functions, such as tag average functions and those, might require a lot of data depending on the time range of the calculation we're doing. Let's say we're doing a yearly average. Now, depending on the density of your data, this could be a bit of expensive function, especially if it's being triggered every minute. If we're doing a yearly time range average, it might make more sense to do it less frequent, such as maybe daily or less frequent than that. And you can also utilize the exit function that I mentioned earlier. Other optimizations that we can do is at the pipe point level itself, at the data source. You can enable compression, which will help you with the density of the data. Let's speak a little bit about event frames and notifications. Event frames, the basics of it are some important events captured for you in a database that have a start time and an end time. They're really good for reports, comparisons, and tracking. You can utilize the calculations to generate event frames based on some start triggers and end triggers. So you can define when you want to start an event frame and when that event frame should end. Well, what's really important also in addition to that is you can capture now data points around that event frame. Let's say when the event frame closes, you want to know the average of temperature around during that event frame, during that event. And you can save that data back into the event frame itself or a pi tag. So at the close of the event frame, you can perform calculations that can be stored with the event frame. And then on top of that, you can use visualization tools such as PyVision to see your event frames and the data points with the event frames. In addition to generating event frames, there are many cases where there are interested parties that want to be notified when these events occur. And to do that, you can utilize the event notification rules. So what this means is you define a notification rule and you specify the criteria on when you want to be notified when a certain event occurs. The emails that are sent to the interested parties can contain a format that you define, and then they can actually also have information about the event itself, the data points around the event, and they could even have a snapshot of a trend embedded within the email for that event itself. So it's very useful information that can be provided to the interested party at the frequency of the event. And this can be done at the start of the event and or the close of the event frame itself. Now let's say as I said earlier, if we're working with a large number of calculations, hundreds of thousands or even thousands, and we want to perform bulk operations, such as we want to recalculate a bunch of them or backfill, or we want to start or stop certain ones. You can do this using the management user interface. You can define searches in there that are stored on your machine per user. So there are your searches, and you define the criteria on what you're searching for. For example, we want to get all the calculations that come from a certain template, or all the calculations that start with a specific name, and you can use wildcards in there, and then you get a list of those. Once you have all the calculations, now you can select the ones that you're interested in here and perform the operation, such as backfilling, where you can specify the time range, a recalculation. In addition, you can also cancel a recalculation that is in progress for a bunch of calculations using the management UI. Speaking of recalculation and backfilling, the difference between the two is that recalculation wipes out the data in the past and recalculates new data. Backfilling, it just fills gaps. So the idea is to not overwrite any data if the data already exists for backfilling. One thing that Nitin also mentioned that is important to reiterate, the real-time versus recalculation, these are two independent workers. They do not interfere with each other, but by default, the real-time has higher priority. Another thing that I would like to mention is that every time you do a manual recalculation, it's a really good practice to also recalculate dependent calculations. So this is really helpful for data consistency, because if your parent calculation is recalculating, you also want the children, the dependent ones, to have also the latest data based on the recalculated data, because you can kind of get out of sync there. Auto recalculation is a similar mechanism, except if you're getting out of order events, then auto recalculation kicks in automatically and recalculates the data for you in the past. You really want to enable auto recalculation only if you want the data in the past to be recalculated. And you can do this per calculation or per template, or by just going to the management UI and enabling the auto recalculation for specific calculations. You probably don't want to enable auto recalculation if you don't want your data in the past to automatically be changed, or you don't want the data of your dependent calculations to be changed, because auto recalculation will take care of that automatically, starting with the parent and all the dependent calculations. Similar to auto recalculation, auto-backfilling is another concept that comes to help, especially if you have downtime. For example, you have scheduled maintenance and your system is going to be down for a certain period of time. You really want to have auto-backfilling enabled, because what happens is when the service comes up, it queues up a bunch of auto-backfillings and it goes and fills in the gaps for you automatically. Now, while this is happening, real-time is not being interfered here. Real-time is continuing with its own operations. Auto-backfilling is just making sure that at the downtime, the data is filled. Let's speak briefly about the change management. We wanted to throw this out here just as a good practice and a recommendation that we recommend that you should have a development or a test environment in parallel to your production environment. This is very useful, especially if there are multiple people making changes in your system, and it's easier to isolate issues. So through a controlled process, you can easily make sure your calculations are ready to be moved into production. Because if a lot of people are making changes at the same time in production, then the possibility of having issues are much higher. This also helps with upgrades. If you get a new version, you can upgrade it on your development or test environment first, and then see how it does with production. For enterprise-wide systems that really do mission-critical operations, we recommend that you have HA or high availability set up for our product. This comes out of the box using Windows Server failover clustering. And in addition to that, you want to enable pipe buffering, so you don't lose any data if, for some reason, one of the nodes goes down. I think that kind of brings us to the end of this, and I would recommend that you listen to the recording from the asset framework talking that happened today if you haven't attended it. There's some useful information there. Also visit us in PySquare, where you can actually ask questions and discuss things that matter to you and what others are doing around asset analytics. So with that, I would like to thank you for your attention and open the podium for any questions. So please, if you have any question, if you don't mind to stand up by the microphone over there and ask any question. And if there are hard questions, we have our product manager here, so he's more than happy to answer them. Thank you. Anyone? We have any brave one? Do you mind if Steve brings the microphone?
Are there any metrics that we can monitor in real time to see how much resources are being taken, if it's potentially going to crash, or a certain month the analysis engine was consuming a lot of resources compared to another month, stuff like that?
Sure. One quick thing you can do is enable performance counters around the asset analytics, which will give you some idea around memory usage, calculations, skip values, and so on. A new thing that we just added into the latest release is that you can use the AF SDK to hook up and query for how the service is doing in real time. AF SDK, which is a C# way of hooking up into the system. And that can give you ideas how the system is doing, if there are any skip calculations or if things are falling behind. But I think the performance counters will be your best bet to see how the service is also doing during that time. did you have to add anything? Or?
Just David's talk.
Yeah. There's a talk going on right now around the AF SDK and how to use that to access these metrics from the service. But you could probably listen to the recording after as well. It's from the developer track, right? Yeah. Any other question? Steve? Over here. Thank you.
When would you use the performance equations versus the analysis service? Like,
So
what would
are
be
you
the
talking
difference?
about performance equations at the data archive level?
Yes.
So we'd recommend you move as early as possible to use calculations and performance equations in the analysis because there are a lot more features here. But I think there are cases where, such as doing totalizers and some things like that, might be a bit more complex to do into the new system. I don't know if Steve wants to add anything to this.
All right, I'll add a couple of things. So performance equations that you may be accustomed to on the data archive, practically speaking, we advise that you don't go above 10,000 PEs. For asset analytics, by the design that we put in, we can scale much higher than 10,000 fairly easily. We have customers that have gone many orders of magnitudes above that. That's number one. Number two, performance equations on the data archive, they are only aware of pi points, whereas asset analytics is AF aware. So, and from a management perspective, by using templates in asset analytics and in AF, the management becomes much easier for you. So if you have to make one change, you can change it in the template, and all the changes will get rolled out.
So have there been any improvements on the management screen? Because if you have lots of analytics and go to the management screen, it takes a long time to come up, other than the searching, number one. And because you can't sort it, I spend a lot of time trying to go down the list to find the analytic I'm looking for.
Well, the first thing about the improvements around performance, depending on the version, we did make some improvements around loading a lot of analysis because we do paging and such. So that should help with loading a lot of analysis at the same time in the user interface. But as far as sorting, that's a good request, and I think it's in our backlog, but Steve probably can give you more info on that.
We haven't done it yet.
Any other question?
Hi, Dave Spees. I'm actually OSIsoft, but something I've noticed a lot in the past when you queue up a recalculator, a bulk backfill, if someone sees it, and since it's lower priority than real time, sometimes people would get impatient and queue it up again and again, and all three of those queues would execute, which you're backlogging the system more. Will it is that something to still be aware of? Will it recognize that it's already queued and ignore it? It's a kind of a manageability thing. You just want to know not to stress the system if you can avoid it.
Yeah, thank you. The management UI should give you some indication if you look on the status on what's being queued and the progress for every calculation. So if it's already in the process of recalculating, you probably want to wait and not requeue another one unless you have a different time range that you want to recalculate. Other things that could help with the performance of recalculation is there are a few metrics, things that you can configure, such as the threads that are being used in concurrent recalculations. And this could help you speed up things and do things more in parallel. So that's one thing you can use to improve a little bit. And yeah, another thing that Nitin just reminded me is that you can also perform bulk cancellations if for some reason you're not happy with the cancellations that are happening at this time.
Frank with PayPal. Kind of tagged onto that question there. You talked about all these tuning parameters. Is there going to be some sort of guidance on how to do that? I've been having a lot of that sort of problem at my system, and it's kind of hard getting that information on what you can fix to make things run better.
Well, the first point I would recommend is talking with our support people. They should have a list of the documentation and some of these tuning parameters. But if that's not sufficient, it's something that we can talk offline and see what we can do better to give you more documentation around that. Any other question?
So
Yep.
I'll add a little something to that. So for those of you who may be an experienced user, you'll note that we have tuning parameters of some sort that are somewhat hidden. They were purposefully hidden because of several reasons, one of which is that if you change them inappropriately, it could make your system be very unhealthy. So the idea there was that we purposefully hid them so that our tech support folks can work with you individually to make sure that they're tuned appropriately for your needs. So while over the years since we've done that, there's been a lot of requests like yours as to making them a little bit more user-friendly. So that's certainly something that we would look into. But just so you guys know, the original intention was you guys shouldn't touch that. Let tech support work with you to make sure that they're done correctly. So call tech support. I see a couple of tech support guys here. They'll be more than happy to help you.
Any other question? No more questions? Thank you. Appreciate it.